Hi everyone, in this video I'm going to be talking about, one of the most beautiful topics in chemistry, which is called the mole concept. Okay, so this is a very important video and I don't have to stress upon how important this is because the entire chemistry which you study and however much you study is based upon your understanding of your mole concept. So on that note, we'll start with the mole concept. Okay, so now what we already know is that an atom, okay, of any element, let's say of copper, okay, any atom is so small that we cannot measure, the weight of the atom in the units that we already have. We have units like gram, milligram, kilogram, microgram, whatever unit we try, we cannot measure the mass of this atom because it's too small. Okay, so scientists wanted to develop a new unit for measuring the mass of atoms and things which are as small as atoms, so that unit was called atomic mass unit or your unified atomic mass. Both mean the same thing, right? So this atomic mass unit was a new unit which was only and only for measuring the mass of your atoms because they are too small. And you always have to remember that whenever we are writing any number with a u or with the AMU, it is going to signify the mass of atom. Okay, it is not going to talk about mass of a series of atoms or many atoms which we see together. Okay, so but also we at the same time also we have to do calculations, and when we are working in lab we cannot work with one atom or two atoms or 20 atoms. In lab we are working with actual salts and actual elements, so in that case we have to measure them in grams. Okay, so now this was a problem. When we talk about mass of single atoms, we are talking in another unit which is AMU. And when we are doing experiments in labs, at that time we are going to talk about it in grams because we cannot, we have to work with what we see. And since we cannot see single atoms, we have to work with a cluster of them, right? Which is of course in grams. So the main issue was, a bridge. A bridge had to be developed between grams and your AMU, and this bridge is nothing but your Avogadro's number, which is 6.022 into 10 to the power 23. Is that clear? Even if it is not clear, I will try to make it more clear. Now, one atom of any element you think about, okay, one atom is equal to, it has a certain weight, and that weight is going to be in AMU. So let's say I'm talking about carbon atom, I know it is 12 AMU. One single atom of carbon is going to weigh 12 AMU. If I'm talking about oxygen, it is 16 AMU. If I'm talking about hydrogen, it is 1 AMU. Okay, so basically one atom of all these elements is going to weigh respective AMUs. All right, but let's say I want to work in lab with carbon. Okay, in that case I'm not talking about one, not two, but actually a lot amount of atoms of carbon together. So if I take not 1, not 2, but 6.022 into 10 to the power 23 atoms of carbon, okay, that is going to weigh 12 grams. And 12 grams is something which I can easily measure in my lab and it's quite visible to me. So now this bridge is now complete. Okay. Similarly, for oxygen, if I talk about one atom of oxygen, it is going to weigh 16 grams, 16 AMU. But since I'm not able to see a single atom, I want a measurable quantity. So if I take not one, not two, but 6.022 into 10 to the power 23 atoms of oxygen, that is going to weigh 16 grams. Is this clear? Again, for hydrogen, if I don't take 1, 2, but actually 6.022 into 10 to the power 23 atoms of hydrogen, that is going to weigh your 1 gram. Okay, so now basically your Avogadro's number is nothing but a bridge between your AMU mass and your gram atomic mass, and that is what it is. Okay, so with this I will just write a small sentence, and we can use that sentence for any given question which we have on mole concept, and that is going to work wonders. The only basic thing which we should have a basic knowledge of is your unitary method, and if you don't know that, we'll discuss that in a while also. So let's try doing that now. 1 mole, okay, Just write this line somewhere, and I think it's going to work for every different atom, molecule that you have in life. Okay, 1 mole is equal to 6.022 into 10 to the power 23 entities. Okay, I'm writing entities because this could be atom, this could be molecule, this could be ion, this could be anything. Okay, so instead of writing all these three, I'm just writing entities, is equal to atomic mass or molecular mass or ionic mass. Okay, formula mass, or I should say in grams. All right, and let's say that matter that we are discussing is actually a gas. It may or may not be a gas. Okay, if it is a gas or a liquid, in that case it is equal to 22.4 liters. So once you write this line for any element or any atom or any molecule, anything that you have, you can solve any question of of mole concept. I'll do that in front of you and you'll know why. Okay, so now let's talk about carbon. I know carbon has an atomic mass of 12 grams. One single atom weighs 12 AMU, and 6.022 into 10 to the power 23 atoms weigh 12 grams. That I know, okay? There's a table of atomic masses, and which you, of course, have remembered in your 10th standard. If you have not done that, you should do that. At least 20 atoms, starting at 20 atoms K masses, you should know, okay? So now for carbon, if I'm writing this line, we have 1 mole is equal to 6.022 into 10 to the power 23, since carbon is what? An atom, right? So atoms of carbon is equal to 12 grams, because the atomic mass in grams of carbon is this much. And since carbon is not a gas, I think this is going to be enough. Okay. So if there's a question, the question says how many, okay, atoms of carbon are present in 6 gram of carbon. Okay, so now I want to know how many atoms are there in a given amount of mass. Okay, so what I'll do is, since I want to establish a relationship between two things, number of atoms and the grams, so in this line which I already have written about carbon, okay, I'll just highlight these two. So I want this and this. Okay, means number of atoms and the grams. What I have to find out is how many atoms. So this part I have to find out. Okay, and this part I already know is given to me as 6 grams. Okay, so what I'll do is, whatever I want to find out should be on the right hand side. So I want to find out the number of atoms, so I just replicate these two again, but with the number of atoms on the right hand side and the grams on the left hand side, because this is unitary method. So 12 grams have 6.022 into 10 to the power 23 atoms. Okay, of course 1 gram of carbon is going to have 6.022 into 10 to the power 23 divided by 12. Okay, and how many do I have in my question? 6 grams. So for 6 grams it is going to be 6.022 into 10 to the power 23 divided by 12 into 6. Okay, so the answer is going to be 3.011 into 10 to the power 23 atoms. So I think it's quite clear. What you have to do is just write this line, 1 mole is equal to this many number of atoms or molecules or whatever is equal to its gram atomic mass, and that is going to solve your question. Just establish a relationship, write it again, and you're done. Okay, so let's do it for a molecule also. All right, and things are going to be more clearer to us. So okay, now my question is, let's talk about now methane. Okay, methane is actually a molecule. The mass is going to be what? 12 plus 4, which is 16 grams. Okay, now 1 mole of methane molecule, since now methane is a molecule, is equal to 6.022 into 10 to the power 23 molecules of methane. Okay, since now I'm not writing atom, I'm writing molecule, since the methane is a molecule. Okay, above this I was talking about what? Carbon, and carbon was an atom. Okay, is equal to we have to write the molecular mass in grams, which is 16 grams. Clear? Okay, since again CH4 is a gas, so we can also write 22.4 liters at STP. So this STP is very important. What is STP? STP is standard temperature and pressure, and we'll talk about this in detail some other day, but remember this, that only at STP the volume is going to be this much for a gas. Okay, only if matter is a gas. In case of carbon, it was not a gas, so we did not write this line. Now my question is, how many moles are present in 8 grams of methane? Okay, so now of course, as I said, you write this line for the molecule which you want to talk about. So it's methane, so I've written this line about methane. Establish relationship between the two things which you have to establish. So how many moles are present in 8 grams? So the gram thing is here and mole thing is here. Okay, so I want to establish a relationship between this one and this one, which you want to find. You have to put it on the right hand side. So how many moles? So moles is going to be in the right hand side. So 16 grams is 1 mole. I'll just copy this line as it is, but whatever I have to find out is going to be on the right hand side. Okay, for 16 gram it is 1 mole. For 1 gram it is going to be 1 upon 16 mole. And how many moles do I have? I think, how many moles are present in 8 grams? So for 8 grams it is going to be 1 upon 16 into 8. Okay, which is 0.5 moles. Is that clear? So you have to do nothing. Whenever you have a question of mole concept, always remember that you just write this line, okay, for whatever atom, whatever molecule that you may have, and then you just establish relationship. You just, copy that two things which you have to find out a relationship between. And always remember, whatever you have to find out, you keep it on the right hand side. Whatever you already have, you keep it on the left hand side. And that's just unitary method. And mole concept is nothing but simple unitary method. Okay, and mole is nothing but just a number, and this number is just a bridging gap between AMU and gram mass, and that's all. So I hope I was able to make things quite clear. You can practice out as many questions as you can, and you should do that. And thank you so much for watching, and stay tuned for more.